Okay, so today we are going to talk about something that is called household wiring and cables, or general cabling idea. We're just going to recognize certain type of cables and analyze their structure. All right? So without further ado, let me here click on this here, and we are going to take a look at some of the cables. So what do we have here? I'm going to be zooming in and out. So what do we have here? We have some examples of some cables and fasteners. We're just going to ignore the fasteners because the fasteners are the fittings, connectors that go on various devices in order to mount the cables onto, like, for example, an electrical box or a panel or something like that. Okay. All right, so I wonder if you can see this. I hope you can. If not, you'll be able to watch it later on YouTube. Am I recording? Yes, I am recording. Oh, too much. Yeah. Okay. All right, so first thing, we can see a cable with some conductors that are inside that cable. So here's a wire, here's a cable. A cable consists of multiple conductors bound together by some sort of a sheathing, usually PVC, sometimes also complemented with the armored sheathing as well. Different cables serve different purpose as well. All right, so we got some sort of a playlist happening on the. Oh, okay, it's our playlist. And the YouTube playlist is in our announcements. So just scroll down in the announcements, you'll be able to see that YouTube playlist. All right. Okay, so we have a cable here that consists of 3 conductors. 2 of them are jacketed and 1 of them is not. And we have something that says on this cable, it says 14-2, 14-2. And it shows that there are 3 wires inside, but it is called a 2-wire cable. Now, the one underneath that, it's called a 3-wire cable. And you can see 1, 2, 3, 4 of those inside. What's up with that? No, it's not a mistake. And this one is called 14-3. All right, this one here is called 2-wire armored cable. And a 3-wire armored cable. All right, what do we see here? That 14, number 14, stands for something that's called a gauge. AWG, American Wiring Gauge. There you go. Thank you, Brody. All right. Now, why is it that we see 3 conductors here and we are calling it a 2-wire cable? There's a cable. That's the whole thing, whole system of wires enclosed in a sheathing. And we see 3, but we call it a 2. Well, we're considering as 2 something that's the concept is called, well, the concept. Here's the concept of current carrying conductors and other safety conductors, non-current carrying conductors. Right? So here's a current carrying conductor. Here's one that looks like it's white, and here's one that looks like it's black, jacketing. And there's a third one that is just a bare copper inside the whole thing. It doesn't have a jacket. Okay? This cable is used for grounding or bonding. The bond wire doesn't count. Who said that? Ryan said that. Good. All right. So now we're going to stop for a second and we're going to take a look at the basic difference between grounding and bonding. All right, bonding is pretty much joining things together. So bonding in the broader understanding is basically connecting things to other things. However, when we are talking about bonding and grounding, when it comes to connecting things to ground, we are going to distinguish grounding and bonding in such way that grounding, if there is any kind of a point in our system that has an uninterrupted wire connected from it to something that's called a true ground, which means it's either connected to a true ground supplied by the construction company, or it runs outside and has a spike or a metal plate, or properly goes inside actually the earth, the ground. Okay? So it has one uninterrupted pathway from that point, from whatever the terminal is, to a true ground, which usually will be either a spike or a plate or a true ground provided by the construction. Okay? Now, when we have that terminal connected to another terminal with a straight wire, that secondary terminal, it's also electrically connected to that true ground, but it doesn't have a direct pathway. It goes through another terminal first, and it's joined there, and then it goes to the true ground. So that terminal is considered bonded. What do you mean by bonded? It is connected to ground. It is bonded to ground. But generally, we're just going to say that terminal is bonded, and the first terminal that goes through a true ground is grounded. So that's basically the jargon that you're going to hear. So in here we have, in the two-wire conduct cable, is that there are two current carrying conductors and one bonding conductor. All right. Now, true ground, we're going to talk about that in later time here. I don't want to get into that. But basically, a true ground is a connection to a ground. So basically, it has either a spike driven into a earth ground outside, or a metal plate, or any other ways that is considered by the local electrical code is considered as a true ground or labeled as a true ground. There are various ways of grounding. Plate or a spike, usually. Now, over here we have three current carrying conductors, so it's in 14-2. So that 14 stands for the gauge, and gauge basically describes the thickness of the wire. How are we gauging the wire? We are describing the thickness of the wire with a number. Okay? And we'll talk about that in the next few slides. So this number tells us, 14-2, tells us that there are two current carrying conductors, and they are, the thickness of them corresponds to the American wiring gauge, which is AWG, number 14, which is a certain thickness. And if this is a 14-2, you're going to have a bare copper inside, which is the bonding wire or grounding wire, usually called bonding wire. And you're going to have white for the neutral, and you're going to have black for hot. Now, when we add one more wire, we still have the white conductor for neutral. We have black as hot, and we also have red as hot. So those two hot wires would be red and black, and the neutral wire is going to be always white. What does it make it a neutral wire? The neutral wire is at the same potential as ground or bond. So if you put a voltmeter between this white wire here and this bonding wire, you should get no voltage reading at all. It has the same potential as the grounding wire. Then we have something like two-wire armored cable, and you can see that it has two current carrying conductors, and it also should have, I don't see it, it should have the bonding wire as well. And here's a three-wire armored cable as well, three current carrying conductors. What does it mean? What do we mean by saying BX? Yes. By current carrying conductor. A current carrying conductor under normal conditions is supposed to carry a current, electric current. Electricity is going to flow through those wires. Those wires are going to be used to complete an electrical circuit and make something work, provide service to something, to some device. Is it going to be a light bulb, or is it going to be a toaster or hair dryer or whatnot? All right. The bonding wire under normal circumstances is not supposed to carry a current. It is supposed to serve as a safety feature. If something goes wrong, that wire is supposed to take the hit instead of you. For example, if you touch something in the wrong way. So we have two current carrying conductors in 14.2 and three current carrying conductors in 14.3. And that 14 stands for the thickness of the wire, stands for the gauge. And here's an example of electrical panel that you will be playing with next term. Right? Some other symbols, among others, you're going to see something that's got UF, right? And that stands for, can I see this? Right. Underground feeder cable. And when you download this PDF version, you can click on that to find out more about that. It also could be labeled as UFB, as underground feeder direct burial cable. Some of the cables can be used underground, but they have to be enclosed in something. And some cables that are called direct burial cable, which means it could be just put in the ground all by itself. It's all subject to the rules and regulations of set by the local electrical codes to wherever you are. It could be in Canada, it could be in the United States, it could be in Europe. Always refer to the electrical code. All right, common household cables and wire types. All right, so the first thing we see here is a solid core wire or a stranded wire. I'm going to stop here for a second, and I'm going to call up another slideshow within the slideshow. Where is it? Here. Solid versus stranded. So it's a branch off a little bit. Well, this is what solid wire looks like. And this is what a stranded wire looks like. We are using those accordingly to the purpose of what they're going to be serving. And they're, so I just put a little thing here for you. You can have it, you can download it. So solid core wire, let's take a look at this. Description: a single strand or a core of wire insulated with non-conductive material, or it could be also non-insulated if it's a bonding wire. As opposed to stranded, it would be a bundle of small gauge wires insulated with non-conductive materials, or it also could be uninsulated, but we're just gonna stay with that. Usage: where do we use them? Household and commercial installations. Here's the key: permanent mount. Typical in-wall power cabling. Now, where do we use the stranded cable? We can also use it in household and commercial installations. Permanent mount. And here is this key here. So it's also permanent mounting, yeah? But moving and vibrating parts. Typical industrial equipment cabling, as opposed to the solid core, which would be typical in-wall power cabling. Why do we use stranded cable or stranded wires in the industrial equipment or moving or vibrating parts? Well, if the cable is stranded, it does not transfer the vibrations along its length, and it stays more put in screw terminals or whatever other connections. It's more flexible. Whereas the solid cable, it would transfer the vibrations along its length, which could cause some loose connections or even wire breakage. If you look under the hood of your car, you are going to find stranded wires, because car has an engine and the engine sends a whole bunch of vibrations, and this would be the choice of wiring: the stranded cable. Can you use stranded cable in an in-wall household wiring? Yes, you can, except stranded cable is much more expensive to produce, so it's more expensive to buy. So most of the time you're going to see the solid cable. Also, okay, well, there could be some other reasons, right? And we'll talk about that in a few seconds. It is less expensive to produce the solid wire, more compact diameter for the same current carrying capacity as stranded. Simply because it's going to take the same gauge or the same current carrying capacity that is needed for a wire. If we have one solid piece, it is going to be more compact, so of course physically it is going to take less space. For the same gauge or same current carrying capacity in stranded, you still should have the same amount of copper, but look, you're having a bunch of smaller gauge wires bound together. So just by that means, physically, this whole thing, if you're going to have the same amount of copper needed, physically it is going to take more space. So the stranded cables for the same ampacity, and ampacity, I'm talking about current carrying capability. For the same ampacity, the stranded wire, yes, it's going to take more space, simply because, it just basically that's what it looks like. And if you bind those smaller strands together, they are going to take more space. Advantages we're talking about still. So solid is more compact for the same ampacity, and also here's a choice. If you can get away with that, and house does not vibrate, the walls don't vibrate, unless you get one of them vibrating houses, they're less likely to fail due to corrosion. Why would they be less likely to fail? Yeah, vibrating houses, yeah. I don't think they exist, although, you know, maybe somebody's going to invent one and make millions. Just take a look at these two cables. Here's wires. Here's a solid core wire, and here is a stranded core wire. The solid is more compact, and it has certain amount of its area exposed to whatever elements, oxygen, air, moisture, or whatnot, other chemicals. Now, this one here, if you add the exposed area, every single strand has exposed area, more exposed area, more exposed area. So per the same amount of copper, more area of volume of this cable is going to be exposed to the outside elements. So that's why this is going to still corrode, but not as fast as the stranded wire, which is more exposed to the outside elements. Disadvantages of the solid cable, or wire, sorry, I keep calling it cable, wire or conductor. Typically only available in smaller gauges, which means you should only have it so thick. If it gets too thick, then you're not dealing with wire anymore, you're dealing with a metal rod. Right? So it's, you know, solid is not as flexible. It's going to be harder to handle. So some of the thicker wires, most of the time you're going to see them in the stranded version, just because it is easier to flex, and the thicker the cable gets, the heavier it is to handle. Right? So what did I write here? Typically only available in the small gauges. Continuous flexing or vibration will cause the wire to fatigue or break. I thought I posted that, but maybe I didn't. I'm gonna check it. Yes, this will be posted. You'll be able to download that. The presentation, the other presentation that I have, should be already there. But I think I posted both of them. Right? Okay, let's talk about the advantages and the characteristics of the stranded wire. Right? Description bundle, yeah, we talked about that. Household and commercial, we can use that, but it's more expensive. Plus, if you can have something that's less expensive and less likely to fail due to corrosion, then I would choose the solid wire to wire up my house instead of the stranded wire. But if you use a stranded wire, it's still going to be received by the inspector. Unless it's not. All right. Okay. Used on moving and vibrating parts. So if you go into industrial electrical type of field, you're going to deal more with or if not all, the wires that you're going to be dealing with would be stranded, because you have electric motors, machines, conveyors, and whatnot, and all that sends vibrations down its structure. Typically in industrial, okay, very flexible as opposed to the solid, and withstands greater amount of flexing and vibration, and easier to route. So it's easier to install, as you know, around the corners and whatnot. Agriculture would be more solid then. Well, that depends. If you're talking about agriculture, if you're wiring a barn or a house or whatever permanent structure, that basically behaves like a solid non-vibrating structure, then yes, you would probably use the solid wires. But if it's some machinery within that structure, then that machinery would be wired with the stranded cables or wires, right? Now, the disadvantages, the diameter is larger for the same current carrying capacity than the solid is. So if you run one or two of those wires, no problem. But if you have a whole bundle of them, then yeah, it's going to take up more space, right? And things do add up quickly when you're pulling multiple wires, installing multiple wires. But also, it's another disadvantage of that is it's more likely to fail due to corrosion from the capillary action and a high surface area. All right. So basically, what I explained to you. Why are homes wired using solid rather than stranded? Stranded is more likely to, okay, what did I say here? Stranded wire is more expensive to make. Why are homes wired using solid rather? Yeah, okay, stranded is more expensive. Well, okay, we just talked about it, and if you read that, you're just going to find whatever I just said. And you can expand on that if you want. There's some references that I got the information from. Some of the sources you can expand on that knowledge. You can explore some of those if you wish. I'm required to provide the references. And here is that AWG, American Wire Gauge. American wire gauge. So it's basically that describes how thick the wire is. Now that's it for this one here. We're going to go back to the original programming here. All right. Zoom in a little bit. So look, we just got as far as these two. Red and green show here. Here's an example of a solid wire, and here's an example of a stranded wire. Here's another thing that's going on here. Multi-conductor cables. Type NM stands for non-metallic sheathed cable. 12-2. Well, the gauge of that is 12, and it has two current carrying conductors. That's basically what that says. Non-metallic, well, it's a PVC jacketing. So we have the, what do we have here? We have the neutral wire, which is always white. The neutral is always white. And then the other colors are going to be mostly hot, unless they're not. Right? So here's the hot wire, that's the black one. And here is the grounding wire or bonding wire. And we all know what the difference between grounding and bonding is now. If not, rewind. Okay. All right. Type non-metallic sheeted 14-3. An example, right? 14-3. 1, 2, 3, 4 cables or conductors. One of them is bare copper, which is the grounding or bonding, and the grounding or bonding wire should be either bare copper or green. Okay. So all the other ones are going to be hot, except for the white, which is the neutral wire. And the neutral and the bonding wire should be at the same potential. Even if they are not electrically connected, they still should be at the same potential. Which would be the ground potential. So then we have the grounding wire or bonding wire, neutral, and then all the rest is hot, black and red. Right. So here is the non-metallic sheeted cable 14-3 for interior circuits. Contains 2 hot wires and 1 neutral. So the hot wires and neutral are considered as current carrying conductors, And as I said before, the bonding wire, it is not a current carrying conductor. It's a safety pathway. Provides a safe pathway for the current to escape if something goes wrong. Large appliance cables. Here is the one that has thicker cables, and we'll talk about the thicknesses, the gauges, and the ampacities of that. But that's what it looks like. And here is the armored cable for interior circuits only. Okay. LMC stands for the metal clad. Cladding is embedding, surrounding, embracing. The cladding is a quite common term that is being used in the electrical industry or data industry or cabling industry. Right? Cladding. There's another data cable is CCA, copper cladded aluminum. So it's aluminum wire, which is cladded with copper, which means it's aluminum wire. Aluminum wire cladded with copper, coated. All right, gauges. Next slide here. Is that what we had here? All right. Gauges. Common gauges, and that's how they compare. Of course, on your monitor, they're going to have different thicknesses, but that's how they compare if you reference them with each other. So one thing you're going to notice that here's the 14 gauge, and when you see something that you can see in electrical wiring business, when you see 14 AWG, you're not going to read it AWG, you're just going to read 14 gauge. That's how gauge is spelled, sort of unofficially, right? So here's 14 gauge, 12 gauge, 10 gauge, 8, 6, 4, and the numbers go down, you see? But the thickness goes up, right? So they're inversely proportional. The number is inversely proportional to the thickness of the cable. The higher the number, the thinner the cable is. And the lower the number, the thicker the cable is. So here's 14 gauge. That would be just a normal household wiring that you're going to find in your walls. That wire connects the power receptacles. For the most part, unless you're going to get 12 gauge wires for certain applications. Right? So 14 or 12, it's going to be the most you're going to see. But there are other thicknesses. Look, when you go down to 10, the cable goes thicker, and starting with gauge number 8, I don't know if this picture is in any of your books. So once you start getting to the lower gauge numbers, which means the cable gets thicker, you're going to notice that they are marked as stranded wires. Okay? And here the cross section of that. So that's all I got to say about the gauge right now. Thing to remember is, for now, the bigger the number, the thinner the cable is. Or the smaller the number, the thicker the cable is. All right, let's just take a quick look at some of the. Oh, go ahead, jumping on me too quickly here. All right, I think this should be fine. All right, household wiring. The most common type of cable used in houses is technically known as NMD90. Okay, is it always true that starting at 8 gauge, it's not a rule written in stone, but you're going to see, for the most part, that's what you're going to see. I have seen some pretty thick cables, but they're probably special order that they were made out of solid copper. Right? And where did I see them? Have seen them in some specialized areas that have equipment racks, computer equipment racks, and when you have the AC applied, the alternating current applied to the equipment, it involves transformers. Transformers produce noise and whatnot. So then you're going to have to filter things out and whatnot. So in some special cases, when it is important to have as least amount of noise as possible, and when you have large amounts of equipment, then the equipment is not powered from the regular AC outlet. It is actually getting direct DC into it, and the wires that run into those rooms with hundreds of switches and whatnot, they will be thick copper wires, and those will be solid wires. However, this is far and few in between as far as the regular industry is concerned. So for the most part, you're going to see the gauge number 8. The kind of gauge number 8 is the kind of like a threshold there. But in some special cases, are you going to see the deviation from the rule? Yes. It's not like it's not illegal to make a thicker wire that's solid, right? All right. So okay. So the most common type of cable used in houses is technically known as NMD90. So NMD stands for non-metallic dry service cable. Okay. It's just kind of, if you just keep reading it quickly, it's going to skip your attention. But service cable, we'll talk about that in the next class as well. Service cable provides electrical service. It provides electrical power. What other cables could there be other than service? Well, there could be data cables. There could be signal cables, antenna, whatever else. So microphone cables, speaker cables, whatnot. So that would not be a service, considered as a service cable. It doesn't provide a power to something, right? Like a toaster or a vacuum cleaner. Right. So non-metallic, it refers to the sheathing of the cable. Sheathing is the jacketing that surrounds the whole cable. The other thing that surrounds the individual conductors is usually referred to as jacketing. But sometimes you're going to hear the terminology reversed for depending on who is talking and who is writing things. Okay, so non-metallic. So it's a non-metallic sheathing as opposed to the armored cable, right? Which has a metallic sheathing. Right? Dry, it is supposed to be used in a dry environment. Simple as that. And the cable is, so here's the 90 thing. The cable is rated at maximum of 90 degrees Celsius, not Fahrenheit. NMD 90, it should be okay up to the environment in which the temperature is 90 degrees Celsius. It's funny that I don't describe the lower part. I'm pretty sure there is some. Now it makes me want to research that. So what's the water boiling temperature in Celsius? It's 100 degrees Celsius. So you would not be able to touch that with your hands, and the cable should still be intact. What's our body temperature in Celsius? It's 36.6 degrees. Our normal operation, if you're not sick. So 90 degrees Celsius is quite hot, right? The brand name that is commonly used is Romex. So Romex as a brand used to be pretty much the only brand some time ago that would produce these type of cables. So some of the, I would say, older electricians, they would just refer to this as Romex cable. Right? Bring me a roll of Romex. You might hear that still somewhere. You know, some of the younger electricians may as well call it that too. But now Romex is not the only company that produces cables. Now everybody and their brother produces cables, so there could be different. Same as photocopiers used to be called Xerox. Can you go and where is your Xerox machine in your office, right? So that, but then other companies came on board, and then the machine is called as a photocopier, right? All right, so cable is okay. So NMD90, it's a common cable. NMD90, non-metallic, dry, up to 90 degrees Celsius environment. The cable is usually configured as 2 or 3 conductor combination. 2 conductor having a black and a white, which we talked about, and a bare copper wire. The bare copper wires, it is never counted as a conductor in the conductor count. So we just talked about that. 3 conductors has a black, red, and white conductor and a bare copper wire. The conductors are most commonly 14 gauge. The cable also comes as 2 and 3 wire in the 12 gauge configurations. Yeah, a bit of a mouthful here. All right, household wiring, how are we doing? We're almost done here. Most commonly used cables and their uses. Well, 14.2. See, I got 14.2. 2 conductor number 14, so it's 14.2. Where is it being used? Right? Plugs, switches, lights, and here's the thing. It's pretty much about 70% of your house wiring would have the 14.2. So most of the wiring in your house would be 14.2. NMD90, right? 3 conductor, 3-way switches. We will actually have an assignment that has to do with that. And split receptacles. A split receptacle is when you have a receptacle, just a regular receptacle. Those prongs, here's a duplex receptacle. They're internally connected, and the grounds or the bonds, they're internally connected. So here's a terminal, here's a terminal, here's a terminal for those, and here's also a terminal for those, and they are pretty much here kind of connected like that. So if you connect one of them to the feeder cable, you are going to have both of them working. So it's just like a splitter, right? Duplex receptacle. Sometimes you might want to interrupt that link, that you're going to have a separate hot wire going, or you can interrupt the whole thing, that you can have 2 separate cables going, but usually the hot one is interrupted. The neutral is servicing both of them, and the hot wires are going to, but that depends on what you want to do. So those are usually, so you can separate them. So that's going to be called a split receptacle. Right? Usually those are being installed in around kitchen cupboards where more current is needed, especially in the morning, right? Let's say if you plug in a toaster in one of them and you plug in something else like a coffee maker in the other one, that may take more current. Those devices combined together may request more current from the circuit breaker than the circuit breaker is designed to give. And if it requests more than the circuit breaker says no, it's just going to flip and it's just going to disconnect. So that's why around the kitchen cupboards, we are mostly using split receptacles. Basically, if it's a 15 amps and 15 amps, then you have in that whole thing, you have 30 amps total instead of just 15 if it was a not split receptacle. Right? So plus Yeah, sometimes also the gauge is being upped, or the wire is being the wire that's used is being used thicker wire to provide more amperes, all right, to increase the ampacity. Also, when you have usually cables or branches, which is the branch going from the receptacle from the circuit breaker going further and further and further. If it's longer than 100 feet of the length, then you also should use bigger gauge, which means lower gauge, thicker cable, right? But you're going to talk about that in further classes. All right, so summary of this slide here. Most commonly used cables, 14.2 or 14.3. Three-way switches, obviously they need more conductors, and we will analyze those as well in later classes. And split receptacles, yes, because they need more wires. All right, most commonly used cables and their uses. For 12.2, right? Selected heaters. Heaters need more current. They take more current from the receptacle. So if you need more current, you should increase the circuit breaker, but not only that. If you increase the circuit breaker ampacity, and if you do not make the wires thicker, then you can actually, those wires can heat up to the point that they can actually start a fire. Yeah, we'll talk about the during the labs, you'll be able to see those taps there, right? And a lot of them are being just used by the students on and off, practicing the termination, and a lot of those taps are broken. But I will show you those. We'll show you those, okay? On more than one occasion. All right, so 12.2. Selected heaters, air compressors, etc. Anything that uses a maximum of 20 amps. Kitchen receptacle circuits as well. Right? Sometimes they're required. 3 conductors, gauge number 10. See, the gauge goes down, which means the wire gets thicker. Any device that requires maximum of 30 amps. The most common application would be the electric dryer. That's the one that you use the dryer that stands right beside your washer, right? 3 conductors, number 8. Look at that, maximum of 40 amps. So number 8, the gauge number goes down, the thickness of the wire goes up, and of course there's more amps. 40, 30, 20, 15. Okay, so for the 3 conductors, number 8, the most common application would be the electric wrench. Electric wrench is just another way of calling a stove. Right? Household wiring. Okay, I'm pretty sure you already had some exposure to what parallel and series is. I'm just going to pull up a question here. Household wiring is done A, in series, B, in parallel, C, depends upon the code in your area, E, using wires dummy, which means whichever way is easier. Right? So can you type some of the answers? Is it A, B, or C? Or somebody forgot to put a D in there, right? All right. Okay, we have some A's, we have some B's. All right. Okay, well, the electrical wiring in a household scenario is used in parallel configuration. Let's just take a quick look at a branch. So there's a terminal here. I know what, I'm just going to lower the light a little bit so we can see things better. You can see less of me and you can see more ink. There we go. All right. So let's say there's a branch, there's a couple of terminals here. Let's say this one is hot and this one's going to be neutral. Forget about the, just assume that it exists, the bonding wire. All right, so here and here. Okay, let's say you have a TV here, you have a toaster, all right, and you have your fridge. Okay, when you connect them in parallel here, just like that, you can turn on and off any of those devices without the other being affected. Unless you got a dead short, yes, of course. But if you connected them this way, here, let's say this would be the neutral. I'm going to reverse that. And this would be the hot. And if you had one going to the TV, all right, the other one going to the toaster, and the other one is going to the fridge, and here's the circuit closed. So this would be done in series. What do you have to do? The fridge has to work all the time, but in order for the fridge to work, the TV and the toaster have to be on all the time. It just doesn't work. It's just not practical, is it? Right? So here is the parallel. Yes. Series. No. Okay. That's how the electrical wiring is done in the common household. Yeah. Do we have any more slides here? Oh, okay. And that's pretty much the last one. Okay, this second last one, I'm just going to let you print or download and analyze some of that if you have any questions, or this is just basically just giving you the whole overall picture of what kind of devices are being used in typical household environment, and we can we'll keep coming back to that slides. Typical wiring in a household will include all of these and more. Can you identify a common device that is missing in the and it's required by law? So I don't think you can. Oh, all right, there you go. Can I put it on the screen? Yes, I can put it on the screen. Here's that screen. All right. Sorry about that. Okay, so typical household wiring. There's something missing that is a common thing that is required by the law. So I will just let you take a look at this thing at home when you download this, if you haven't already. And I'm going to ask you that question next time we see each other, which is tomorrow. Now, service conductors. Is that the last slide? Yes, this is the last slide. Almost done. Service conductor. There are specific cables used to carry power into the house to the service panel. Remember when we talk about service, that we're talking about providing electrical power to power up things or to power things up, all right? These are referred as service conductors. Service conductors that are run overhead are generally made of aluminum, or in UK they will be called aluminium. Same thing. All right. So overhead, what does it mean overhead? It basically runs in the air between one pole and the other pole, and it's just extended in the air from the electrical pole or utility pole into the house. It's hanging in the air. Right? So those cables are aluminum, and the purpose of that is to reduce the weight of the cable. Copper is a better material to produce conductors. It doesn't deteriorate as much. However, copper is much heavier than the aluminum. So for the purpose of running them overhead, aluminum is being used instead of copper. But of course, a lot of those cables right now are being buried underground, so you don't even see them overhead. Right? Okay, so this is the last slide that we had, and we are pretty much done. So There is no roof. Yeah, there's no roof. This is the roofless house, the new one. Okay, same as the vibrating. Gotcha. This thing was flying all the time, and it was just trying to get into my eyes. All right, there you go. Fruit fly, convertible house. Yeah, cabrio. Right. Yeah. All right. So we're going to see each other tomorrow. I'm going to see one of the sections in the lab tomorrow. I think it's a section 3, but I think it's a section 3. So take a look at the schedule and show up. Show up with the PPE, personal protective equipment. You need safety glasses, you need a hard hat, you need safety boots. If you don't have it, I'm not allowed to let you in. So please do not just come to me with a question or with a statement like, yeah, I forgot my boots, but it's just today. I promise to bring them next time. No, I'm not allowed to let you in that room. That's as simple as that. Because if I do let you in that room, I can get in trouble, and I don't want to get in trouble. Right? So bring your basic tools. We're going to practice some terminating of the 14.2 NMD90 cable. So bring your tools, bring your PPE, and I'll see you tomorrow, and I'll see the rest of you tomorrow during the lecture. Okay, so that's pretty much it. And thank you, whoever that was, for not making those noises. In fact, if you're here, why don't you make noise right now? If you really, really can't hold it on, if you just, it's in you to give, you can make a noise right now before I close the session. Go ahead. That's going to be your reward for being quiet. No? Okay. All right. Thank you so much, and I will see you when I see you. Bye. Hmm.